Today we are doing this problem called partition list, and the problem says we get a linked list and the value x, and we want to partition it so that all nodes less than x come before nodes greater than or equal to x. And we should preserve the original relative order of the nodes in each of the two partitions, which means basically we should keep them in order but just push them to the left of x or to the right, depending on where, if they are less or bigger. So let's illustrate that with this example here. So the example we get is this, and x is equal to 3. And so the result is this one. So you can see here that we have 1 which is less than 3, so we put 1 which is less than 3 here, and then 4 bigger than 3, so it's here. But you can notice that all those less than 3, which are 1, 2, 2, the order is kept here, and all those bigger or equal to 3, that's 4, 3, and 5, they are kept in the order they appear in the list. It's not the order, they're like ascending order. If that was the case, we would have had 3, 4, right? So yeah, this is how the problem works. And so you can think of this as, well, the natural thing we see here is that we are kind of going through the list, right? We are going through the list, and we are so we are going through the list, and we just take the value and decide whether to put it in the before or after, right? So let's just, the way we can think about this, okay, let's think about them as two separate lists, and then they get joined together at the end, right? And so we need a list that for the before values and the list for the after values, right? And then once we have those, we can just say, okay, let's say we have the before, let's say before pointer, and then we would have before head, right? And then we would have after head, and then after, which is the pointer to the tail of the before list, right? And this is the pointer to the tail of the after list. And so that means we will need to connect the tail of the before list to the head of the after list, which means the tail of the before list is this 2. We need to connect it to the head of the after list, which is this 4. And so that would mean here the after head, right? And so once we have this, we can so once we have the before and after list, we can just connect, and we need to return the before head, right? We just need to be careful, again, as always with the linked list problem, with cases where there is just one node, or there is just, like, let's say 1, 2, and all of them are in the before list, things like that. And so, or for example, let's say we have just 4, 3, and the list, the x is 3, then there is no before, and so returning before head would be just returning null, right? So we'll need to be careful of that. And the way to remedy that, as always, also, is to create a dummy node for the before head and a dummy node for the after head, the after list. So this is dummy, this node here is dummy for before, and we will need a dummy for after. And then this way, basically, our dummy before would take as its next value the before head, and the dummy of the after will take the as its next the after head, pretty much. But it would be easier actually to just say, okay, dummy before instead. Let's just name this before head and just get rid of the entire thing. And so that before head dot next would be equal to something that we'll set later, and we'll initialize after head to be equal to this, pretty much. That way, when we are setting here, instead of doing this, we'll do something different, because after head starts out with a dummy node, which is not what we want to connect it to, because if we do that, we'll end up connecting 0 to something like this, right? And that's not what we want. So we want to connect to the dummy, to the before head, to the after head next, right? That will give us the element after dummy. And for that's pretty much it. And for returning, instead of returning before head, which is this dummy, we want to return next, right? So that we can get a reference to the rest of the list, right? So yeah, let's do this then. So we'll keep traversing, and that way we know whether we should put it in the before or the after list. And so the way we do that is, let's create what we said here. And so our before will start out as this, right? Our before will start at that, and after will start at that too. And we have a head, so while head will keep doing something, and we know we need to advance each time. And so what are we interested in is checking whether it's part of the before list or the after list. So we need to check the head value against x. If it's less, that means we need to put it in the before list. So that means before that next is going to be equal to this node here, right? Which is the current node, which is head, right? And so that would be current, or would be head. And then we need to advance the pointer so that we can, when we are here and we had before at this position, so if we had just one so far, we haven't entered anything, and we have before here, and then we put 2, then we need to move this pointer to 2 so that the next element can be attached to 2 instead, right? So we'll need to do before equal to before that next. And we'll do the same thing for the case for after. And so we would have after here and after like this, and then after that next. And once we do have that, we need to do this connection here. And then after that, we'll need to return. One other thing we need to be careful of is that, let's say there were other things here that are all, let's say our list had these values here, and then after that has only values that are less than 3, like this. So this 5, if we set it as part of the after list, it is still connected to all of these, but that's not what we want. So we want the last element of after to be connected to null, right? And so to do that, we will have just after that next to be none, right? Okay, that sounds good. Okay, let's submit and see if this passes. Yep, so that solution passes, and it's a pretty straightforward solution. You just need to be careful to not leave, for example, this without doing this, because at that point we will put in after this node 5, but it will still be attached to all of the rest, and it shouldn't, right? And so yeah, that's it for this solution. The time complexity is so we are going through the list only once, so the time complexity is O(n), and space complexity is here. We are just using a couple of pointers, 4 in total it seems here, and so we just need to return as space complexity O of 1 constant space, right? Yeah, that's pretty much it for this problem. See you next time. Bye.